Assalamu alaikum students, hope you're doing good. Today we are going to start the problems of Unit 2 Kinematics. So the first problem is 2.1. A train moves with uniform velocity of 36 km per hour for 10 seconds. Find the distance traveled by it. So the train is traveling with uniform velocity and velocity is given to us 36 km per hour. As we know that the SI units of velocity is meter per second. So first of all we have to convert kilometer per hour into meter per second. So what we have to do, we have to multiply 36 by 1000, because only 1 kilo is equals to 1000, right? And 1000 meter then divided by 60 minutes into 60 seconds, right? So we will get 10 meter per second. So this is the velocity in meter per second. The time is given to us, that is 10 seconds, and we have to find out the distance. So we will use the simple formula of distance, that S is equals to VT, right? So we have to multiply by 10 by 10 and we get the answer 100. So the distance traveled by the train is 100 meter. So the second problem is 2.2. A train starts from rest. Its mean its initial velocity will be 0, right? So Vi is equals to 0 meter per second, right? It's moved through 1 kilometer in 100 seconds. So 1 kilometer is will be a distance. S is equals to 1 kilometer, and we always measure distance in meters. So we have to multiply 1 by 1000 meters, so we get 1000 meter. And time is given to you, that is t is equals to 100 second. With uniform acceleration, the acceleration is uniform. What will be its speed at the end of 100 seconds? So we have to find out the final velocity, right? So as by using the second equation of motion, S is equals to VIT plus half AT square, you have to put the values. S is 1000, VI is 0 multiplied by 100, half will remain as it is. The value of A is unknown, right? Because first we have to find out the value of acceleration to then we will find the final velocity, right? And 100 square for time, right? So if we just simplify it, we will get 1000 is equals to 5000 a, and if we just multiply, we will get acceleration is equals to 0.2 meter per second square. So as we have find the value of A, now we will use this value in the first equation of motion to get the value of final velocity. So first equation is given by Vf is equals to Vi plus At. So Vi is 0, acceleration is 0.2 multiplied by 100, and when we simplify it, we will get the final velocity is 20 meter per second. So we are going to start problem 2.3. A car has velocity of 10 meter per second. It's accelerate at 0.2 meter per second square for half minute. So time is here is half minute, right? Find distance traveled during this time and final velocity of the car. So the data given to us is that initial velocity is equals to Vi, that is equals to 10 meter per second square. Acceleration is also given 0.2 meter per second square, and time is 0.5 minutes. First of all, we have to convert minute into seconds. So for that we have to multiply by 0.5 with 60 seconds, and we get time is equals to 30 seconds. Then we have to find out distance and final velocity. First of all, we will find out distance by using second equation of motion, that is S is equals to VIT plus half AT square. Just put the values, 10 into 30, half 0.2, 30 square, and when you simplify it, you will get the answer S equals to 390 meters. Now we can also find out by using first equation of motion to get a final velocity, right? So Vf is equals to Vi plus AT. Vi is 10, A is 0.2, and time is 30. So we get Vf is equals to 60 meter per second. So problem 2.4 is a tennis ball is hit vertically up with a velocity of 30 meter per second. It takes 3 seconds to reach the highest point. Calculate the maximum height reached by the ball. How long it will take to return to the ground. So we have to find out the height and the time. How long it means we have to also calculate the time, right? So the initial velocity that is given to us is vi is equals to 30 meter per second, and the time that is given to us is t is equals to 30 seconds. So the final velocity will be equals to 0, right? So because it's mentioned over here, calculate the maximum height reached by the ball. So at the maximum height the velocity will be 0, and that will be vf, right? So the height we have to find out, that is equals to s or h, and time that we have to find out is t. So time is given, so first of all we have to find out the distance. So by using second equation of motion, s is equals to vit half at square. So here the height is involved, so we can say that s is equals to h, right? This is h, and a is equals to g. So vi is 30 and time is 3 half. The value of g will be negative because the ball is throwing in the upward direction, right? So g will be taken as minus 10 meter per second square, and time is 3 square. When you simplify it, you will get the answer. You can say it as h is equals to 45 meter, right? The total time we have to calculate is time to reach the maximum height and time to return to the ground is so it will be equal, right? So how much time it will take to the maximum height is 3 seconds. So when it will be reach ground, it will be having the same time, that is again equal to 3 seconds. So we just add up and get the total answer, that is 6 seconds. So problem 2.5 is a car moves with uniform velocity of 40 meter per second for 5 seconds. So this is the time it's come to the rest. It's mean this will be the final velocity will be equals to 0 in next 10 seconds. So here we have the two times. This 5s is for initial velocity, and this 10 seconds is for total vi and vf, right? With uniform deceleration, find the deceleration and total distance traveled by the car. So initial velocity is 40 meter per second. First time for initial velocity is t1, that is 5 seconds. Vf is equals to 0 and t2 is equals to 10 seconds. We have to find out the deceleration and distance. So deceleration can be easily find out with the help of by using first equation of motion. Vf is equals to vi plus at2. We use the time t2 because here the total distance will be traveled by the body. So vf and vi are involving, so we will use the time t2. So just put the value and we will get the answer. A is equals to minus 4 meter per second. Then we have to find out the total time. So the first time is calculated for initial velocity, and the second time is for both initial and final velocity. So s1 is equals to vit. Just put the value, we get the answer. S1 is equals to 200 meters. So here we will use the time t1, right? Then by using the third equation of motion, 2a s2 is equals to vf square minus vi square. So just put the value and we will get the answer. S2 is equals to 200 meter, and the total distance will be, by adding them, equation 1 and 2, 200 plus 200 give you 400 meter. 2.6 is a train start from rest. Its mean its initial velocity is vi, that is equals to 0, with acceleration of 0.5 meter per second square. So the acceleration is 0.5 meter per second square. Find its speed in kilometer per hour. We have to find out the speed, that is vf, right? When it is moved through 100 meters, so 100 meter is a distance. Simply we will use third equation of motion. 2a s is equals to vf square minus vi square. Just put the value and we will get final velocity equals to 10 meter per second. Now we have to calculate this speed into kilometer per hour. We know that in 1 kilo there are 1000 zeros, and in 1 hour, in 60 minutes into 60 seconds give you the answer in 3600. So what we have to do, we have to divide 1000 multiply by 3600 and divided by 1000, because this hour is hour is in -1. So when we'll divide by 1 by h, it will be automatically come to multiply with 3600, and this kilo will be divided by 1000, right? So 1 kilo divided by 1000, right? So we get the answer. Vf is equals to 36 kilometer per hour. Now the problem 2.7. 2.7 is a train starting from rest. Its mean its initial velocity is 0, accelerate uniformly and attain a velocity of 48 km/h. So Vf is equals to 48 km/h. We have to convert in meter per second. So what we have to do, multiply by 1000 and divide it by 3600, and we get Vf 13.3 meter per second, right, in 2 minutes. So the time is 2 minutes. That is if we have to convert this minute into second, we have to multiply by 2 with 60 seconds, and we get 120 seconds, right? If it's travel at a speed of 5 minutes for 5 minutes, so again the time is t2 is 5 minutes, so we have to convert this time t2 into seconds, multiply by 60, give us 300 seconds. Finally it moves with uniform retardation and stop at after 3 minutes. So this is the time, third time, and again we have to convert it in seconds and get 180 seconds. Find the total distance traveled by the train. So we have to find out the total distance. So for that we have 3 times, so we have to add all the, first of all we have to calculate 3 times s1, s2, s3, and then add up to get the total distance, right? So by using the first equation of motion, first of all we have to find out the acceleration, right? So Vf is equals to Vi plus At. If we just separate the A and put the value, we get the A is equals to 0.1 meter per second. So first of all we will use the time s1. So for s1 we will use the equation s1 is equals to Vit plus half At square, right? Just put the values over here. This is the time t1, right? When you put the value, you will get the answer. S1 is equals to 720 meter. For S2 is equals to Vt2, just put the value, we will get the answer. S2 is equals to 4000 meter, right? Then for third time we have to write the equation 2as is equals to Vf square minus Vs square. First we have to find out acceleration for time t3 because there is no acceleration. So again we will use the third equation of motion for that. So Vf is equals to Vi plus At, A is equals to Vf minus Vit, or A is equals to 0 minus 13.33 divided by 180, right? We are using the first equation of motion to put the values in third equation of motion, right? Now we will get the acceleration that is formed in the retardation, that is equals to A is equals to minus 0.07 meter per second square. Now we have written the third equation of motion in the previous slide. Just put the values over here and we will get the third time, that is S3 is equals to 1280 meter. Now add up all three distances and we will get the answers. S is equals to 6000 meters. So 2.8 is a cricket ball hit vertically upward and returns to a ground 6 seconds later, right? So when it hit vertically upward, so later calculate maximum height reached by the ball, initial velocity of the ball, right? So when it will be hit vertically upward, obviously it will be go at the maximum height. When it will go at the maximum height, its final velocity will be equals to 0. So and time given to you, that is 6 seconds. We have to find out the maximum height, that is s equals to h, and initial velocity vi. By using the first equation of motion, as we know that the first equation of motion is Vf is equals to Vi plus At. As the ball is hit vertically upward, so the acceleration to gravity will be with negative sign. So A will be equal to G, and that is equals to minus 10 meter per second square. As the time taken to reach at the maximum height, so time required to return to the ground. So as we have the total time 6s, so we have to divide this time. T1 is equals to, we have to divide them equally, right? T1 is equals to 3 seconds and T2 is equals to 3 seconds. So first of all we will use the first equation of motion to find out the initial velocity. So Vf is equals to Vi plus At, just put the value and we'll get the answer. Vi is equals to 30 meter per second. Now using third equation of motion, then A will become G and S will become h, right? So 2as is equals to vs square minus vi square will be 2gh is equals to vf square minus vi square. By putting the value 2 into minus 10, s will be h, right, is equals to 0 minus 30 whole square, so it will be minus 20. H is equals to minus 900, and so s h is equals to 4500. You have to write h instead of s. This is the total distance we have to find out. So problem 2.9 is, when brakes are applied, the speed of a train decreases from 96 km per hour to 48 km per hour in 800 seconds. So initial velocity is 96 km per hour. When you convert in meter per second, it will be 26.67 meter per second. and final velocity is 48 km per hour. If you do conversion, you will get the answer 13.33 meter per second, and the distance given to you, that is 800 meter. And they have to say how much further will train moves before coming to the rest. So we have to find out the distance s1, that is moving with initial velocity, right? Assuming the retardation is constant. So what we have to do, we have to use the third equation of motion, that is 2as is equals to vf square minus vs square. First of all, we have to find out the value of a. So we will get retardation a is equals to minus 0.33 meter per second square. So by using the third equation of motion, that is 2as is equals to vf square minus vs square, here the time is s1 is equals to s equals to s1. So we will put the value to find out the s1, and we will get the answer 26.66 meter, right? So problem 2.10 is in the above problem. It means you have to use the data of problem 2.9. Find the time taken. We have to find out the time by the train to stop. It means when it will be stopped, its final velocity will be equals to 0 meter per second after applications of brake. So vi is given, that is 26.67. We are using the previous one, and acceleration that we have calculated in 2.9, we will use that acceleration, that is a is equals to minus 0.33 meter per second square. Now for time, we will use the first equation of motion, vf is equals to vi plus at. Just separate the time or just substitute the values, you will get the answer t is equals to 80 seconds. So these are the problems. You have to do all these problems in your notebooks, right? And if you have any confusion, you can ask me on WhatsApp as well as on GC in comment box. Okay, thank you.